and welcome to the 6th lesson in measurements for CSEC mathematics. This will be our first lesson for the week. In today's lesson, we'll learn how to calculate the area of a triangle with a new formula, and then we will use that formula to help us calculate the area of a segment. Now, before we start the full lesson, we need to get a couple of definitions clear. The first definition we'll work on is the definition for a chord. A chord is a line segment with both ends on the circumference of a circle. So here and here. Notice that it does not go beyond the circumference of the circle. This chord effectively divides the circle into two segments. Now, I already told you about diameter. Diameter is a special case of a chord. It is the longest chord that you can have for a circle. When we do circle theorem, you'll see more information about chords and how we can use them. The next thing we need to define is a segment. Now, a segment is part of a circle. The segment is the area enclosed by the chord which runs from here to here, and the arc that it intercepts running from here to here. So in other words, that blue region. If you draw a single chord, it creates two segments. It creates a major segment, which is the combination of this yellow region and this green region here. And it creates a minor segment, which is just simply this blue region over here. To find the area of the minor segment, we'll use our knowledge from the lesson on sectors, along with a new formula we can use to calculate the area of this yellow region over here, which is a triangle. Now let's explain how we get the area of a segment. We can see that the yellow region is clearly a sector. When we place the blue region on top of the yellow region, we see that a triangle remains. So this is why the area of the segment will be the area of the sector, which is this piece here, minus the area of the triangle, which is this piece here. But how do we get the base and the height of the triangle to get its area? With a little bit of algebra and a bit of trigonometry, we can obtain the formula for the area of a triangle as a half times A times B times sine theta. Let's look at this example. We're going to find the area of an equilateral triangle that has size of 10 meters and a height of 8.66 meters. Now we're going to use both the formula that we know and the formula that we just learned, so that you can see both of them produce the exact same areas. Let's start solving the problem. The first thing we want to do is we want to draw a sketch of the diagram. Next, what I want to do is I want to use the old formula that we know to calculate the area of this triangle. Next, what I'm going to do is I'm going to use the new formula that we have for the area of a triangle, and I'm going to write that in yellow. Now, when doing this calculation, you need to make sure your calculator says DEG because your angle is in DEG or degrees. If your calculator is saying something else up here, you're going to get it wrong. So notice that we got the exact same area for both of them. Here is one, here is the other. Now that we know how to calculate the area of a triangle, we can adjust the formula to use with circles. Since we're working with the radii that form the arc, we replace the A and B with R, and this gives us a half R squared sine theta. Let's now use this example to determine the area of the segment. First, I draw a diagram. The yellow region is what I want to find the area for. Now we can calculate the area of the segment. So we can see if I add 6 to get 30.5 and I add 8 to get 38.5, then that means 6 and 8 will be 14, and that's the difference between these two values here. Everything from here will be really simple. To determine the area of a major segment now, we just simply subtract the area of the minor segment from the area of the circle. And let's try it with this formula. Determine the area of the major segment of a circle of radius 5 meters and a central angle of 45 degrees. Let's first draw a diagram. Now the blue region is what we want to find the area for, and the green region is what we have to subtract from the total area. Let's first figure out the area of the minor segment. And that's the area of the major segment. And that's it for today's lesson. Let's do a quick recap. We defined a chord and a segment, which is the area between a chord and its arc. Then we explored two types of segments, which is the minor segment, the smaller area, and the major segment, the larger area. We introduced a formula to find the area of a triangle when we know two sides and the angle between those two sides. And we use this to calculate the area for both the minor and the major segments. Thank you for joining me in today's lesson on segments, and in the next lesson we'll learn how to calculate the surface area of solids. Feel free to leave any questions or comments below, and don't forget to join the Google Classroom for the series resources. See you in the next lesson. Bye.